Hi, my name is Manraj Garewal, and today I'm going to go over some of the most important scientific discoveries that have been made in the history of research on Duchenne muscular dystrophy. Since 1791, researchers have been slowly progressing to figure out the causes and potential cures for the inherited muscular disease known as Duchenne muscular dystrophy. Because what we know today is only possible because of research of the past, it's important that we understand how our current state of knowledge came to be. One of the first discoveries that paved the way for DMD research was made by Luigi Galvani in 1791. He is now considered the founder of electrophysiology because of his breakthrough experiment using electrodes to stimulate frog legs to contract. This was the first piece of evidence that muscles had to be electrically stimulated to contract. There were three scientists who were considered the first to characterize DMD as its own disorder. The first report of DMD was made by Gaetano Conte in 1836. In his honor, the Gaetano Conte Academy that researches muscle disease has an award named after him. A few years later, in 1851, DMD was reported by Edward Marion. In 1868, even though he's the last of these three to report DMD, Guillaume Benjamin Amand Duchenne is the namesake of Duchenne's muscular dystrophy, as he provided the first in-depth description of the disease. A few years later, in 1876, Vladimir Karlovich Roth advanced our understanding of DMD by performing autopsies and histological studies on cases of progressive muscular atrophy, and he didn't find any changes in the patient's nervous system, showing that the disease was localized to muscle tissue. He later published a journal called Muscular Tabes, in which he analyzed thousands of cases of neuromuscular disease from scientific literature and hundreds of his own observations, using electrodiagnostic and histological study of muscles to make this report. 70 years later, in 1947, Kenneth Cole and George Marmont formed a novel technique to keep a cell's membrane potential at a set level using electrodes, known as the voltage clamp. Because this was before the invention of microelectrodes, this experiment was conducted on the squid giant axon, which has a diameter of 1 millimeter. Piggybacking off this technique, Alan Hodgkin and Andrew Huxley described how ionic currents give rise to the action potential, and formulated the first equation which could mathematically describe the action potential. Because of this finding, which forever changed our understanding of the nervous system, these two shared a Nobel Prize. In 1958, Hideo Sugita and Tetsuro Ibashi examined serum creatine kinase levels for the first time, which gave doctors the ability to more easily diagnose muscular dystrophies by looking for an elevated amount of creatine kinase in the patient's blood. In 1962, the inherent power of the muscle to regenerate on its own was discovered. Experiments on the quokka outlined that the cause of progressive weakness in DMD was cycles of pathological necrosis and regeneration, which led to fiber death and fibrosis. In 1953, Watson and Crick figured out that the shape of DNA was a double helix using Rosalind Franklin's X-ray crystallography studies. In the 1970s, this supposition was used to fuel research into gene sequencing, now that it was known that DNA was composed of nucleotides whose sequence determined the effects of the gene. Currently, rapid sequencing of patients' genomes are possible through these methods. Finally, in 1978, Louis Kunkel discovered the dystrophin protein, after these gene sequencing techniques allowed him to locate the dystrophin gene in the genome. These discoveries have been critical in the treatment of DMD because they allow doctors to identify which mutation in dystrophin the patient possesses, and to personalize treatment for them based on this. The current directions for a cure for DMD include antisense oligonucleotides, exon skipping, and AAV viral vectors, all of which use genetic techniques that we talked about earlier, as well as stem cell therapy, which uses the regeneration of muscle to the patient's advantage. So in the end, this is only the beginning for research for DMD.